Welcome. This video is CCBYNC. Welcome back, everybody. This is the second part in a 5-part series on how to graph trigonometric functions. We're going to go ahead and tackle the idea of the period, which is also called the cycle. And what I want to do first is throw down our regular old y equals cosine x here. Make that one blue. And if you recall, the critical values are pi over 2, pi, 3 pi over 2, and 2 pi. And if you remember also, we went up and down from -1 to 1. And it starts up for cosine, then down to 0, down to -1, to 0, back up to 1. And if you remember, the graph looks like this. So here's our standard cosine wave. And now we're going to see what happens if we multiply the domain by 2 or multiply it by 1/2. I have two separate pieces here. First of all, notice my x values changed. We'll figure out how to come up with those in just a few minutes. But for right now, you'll notice this goes 0 pi over 4. So that's kind of the in between. And I also put 3 pi over 4. And let's see what we get here. Cosine of 0, 2 times 0 is 0, is still going to be 1. Now cosine, this is actually cosine of 2 times pi over 4. And you can see that becomes cosine of pi over 2. And cosine of pi over 2 is 0. This becomes cosine of 2 times pi over 2 now, which is now the cosine of pi. And the cosine of pi is -1. The cosine of 2 times 3 pi over 4 becomes the cosine of 3 pi over 2. Which once again is 0. And the cosine of 2 times pi means that I'm back to 1. So how is this going to affect us? Well, I'll take the red. I'm going to mark it out. So we start again up at 1. At pi over 4, I'm down to 0. And at pi over 2, which is here, I'm down to -1. 3 pi over 4, I'm back to 0. And at pi, I'm back up at 1. And you can see what this has done to our cosine curve. It has compressed it. So we would actually get 2 full periods where for the blue, the regular cosine one, we get 1 full period. In fact, as that number in front of the x gets larger, the more it gets compressed. All right, let's do the same, but for y equals cosine of 1/2 x. And when x equals 0, cosine of 0 is still 1. When I do cosine of 1/2 times pi, this is now the cosine of pi over 2, which is 0. Cosine 1/2 times 2 pi becomes cosine of pi, which we know is -1. Cosine of 1/2 times 3 pi is cosine of 3 pi over 2, which again is back to 0. And cosine of 1/2 4 pi is cosine of 2 pi. In fact, this graph is only going to end up getting us half the way there. So let me throw down regular cosine again. Here, 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 and here. So regular cosine looks like this. And our new graph, which will be with purple, is going to look like this. At 0, we're at 1. At pi, I'm down to 0. And at 2 pi, I'm down to -1. So you can see I'm only getting the first chunk of this. This continues on. So the 1/2 actually has stretched it out. And these are our critical values here. And you'll notice how different they are. I would have to literally double this graph to do that. And we'll graph one like that in a few minutes. But I just wanted to show you how dramatic they are different. And let's summarize what we have here. And this is going to lead into how do we know how to find these critical points here. Don't worry, it's not hard. Right, our summary is if we have the two functions y equals sine of bx or y equals cosine of bx, then the period is going to be 2 pi divided by b. And if the absolute value of b is bigger than 1, then it compresses it. If the absolute value of b is less than 1, then it expands it. Just like we did with the purple. When b was bigger than 1, it compressed it. When it was larger than 1, less than 1, it expanded. So we have an example here. Part A says, find the amplitude and period of the function. So let's start here for part A. Y equals -3/2 the sine of 2x. The amplitude is the absolute value of the number in front, which is just 3/2. Period. B in this case is 2. So this is going to be 2 pi divided by 2. Whatever that is, goes there. So the period in this case is just pi. And I would like to show you, we did have the 2x and it did cycle once and stop at pi. Next up, part B. Y equals -3/2 cosine of pi over 4x. Amplitude the absolute value of -3/2 or just 3/2. The period, here's my B. So the period is going to be 2 pi divided by pi over 4. Remember when you divide by a fraction, you multiply by the reciprocal? You can see very nicely that the pi is reduced. I just end up with 2 times 4, which is 8. Now, once we get our period, we're going to have to divide it. We're going to take the period and divide it by 4. It's always 4 because we have 1, 2, 3, 4 of those points there. So we take the period for the blue, in this case, 2 pi. and we divide it by 4. 2 pi divided by 4 is going to be pi over 2. So that means I'm going to pi over 2 plus pi over 2 plus pi over 2 plus pi over 2. And that's what we're going to be doing. All right, here we are. So when we graph the function, first off, I'm going to notice that my amplitude is 3 over 2. That's 1.5. So be bouncing back and forth there. The period is 2 pi divided by 1/2, which actually is 4 pi. And remember, we take the period and we divide it by 4. So 4 pi divided by 4 is pi. So we're going to advance every pi. So here are my critical values. So here's 0, here's pi, 2 pi, 3 pi, and 4 pi. These are my critical values. Now we're going to graph it. Sine starts down here at 0. And all the way to pi, I'm going to go up to 3/2, back down to 0, down to -3/2, back up to 0. So here is our sine wave. Try to make it round if you can. I know when you're first learning how to do these, it gets kind of jagged. It takes a while to get it like this. And I'm not particularly good at drawing. I've just been doing this a long time. There it is, our beautiful piece there. Our next example, we have a cosine curve. And it looks like we're going to be going, our amplitude is going to be 3 from -3 to 3. And we now need to find the period. Period, which is going to be 2 pi divided by b. B in this case is 3/4. And flipping that around gives me 8 pi over 3. And for the critical values, we have to take, so the critical values, we take 8 pi over 3 and divide that by 4. Ends up being 2 pi over 3. So we're going to be counting 2 pi over 3 from 0. So these vertical lines are divided into pi over 6s. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. There we are. 4 pi over 6 is 2 pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So I need to go another 4 pi over 6, right? So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And that is going to give me over 3. And then this is going to give me 6 pi over 3. So let's write these down. This is 0, 2 pi over 3, 4 pi over 3. Now next up is going to be 6 pi over 3. However, 6 pi over 3 is just 2 pi. And then 8 pi over 3. So 2 pi is my next one. And then 1, 2, 3, 4. Here is my 8 pi over 3. All right, so we're going to start way down here at -3, go up to 2 pi over 3. And at 4 pi over 3, we're going to go all the way up to 3, then back down at 2 pi to 0, and then way down here at -3 for here. So here is our crazy graph. Again, take your time with this. Draw it out nice and slowly. All right, next up, what if we're given a graph? How do we identify the amplitude in the period? Well, for example, 4 here, determine the amplitude and the period of the function shown below. Well, the amplitude's not too bad. So this is a cosine curve, it looks like to me, because we're not starting at 0, we're up. And we're starting up at 3, so I'm going to say that the amplitude is a +3. Now the period is just a little bit more tricky, not much. Remember, the period is equal to 2 pi over b. That's just a reminder because we'll need that here. But the period in this case is, when does it repeat itself? So we start here, it goes all the way here, and it stops here. So it looks to me that the period is 2. So the period equals 2 in this case, because that's when it cycles again. So now we're going to build the equation based on the graph. So here are my two answers, amplitude and period. We'll need this formula for here. All right, for part A, the amplitude, and this is looking like a sine wave to me. This goes up to 1 and down to -1. So it looks like the amplitude's just 1. Period, do you see it cycles from here to here? So it looks like the period is 10, right? This goes here, halfway is at 5, it would continue on to 10. So the period in this case, and what we're looking for is that b now is equal to 10, which is equal to 2 times pi over b. Well, no problem. That means that b, if I cross multiply and divide, is 2 pi over 10, which is pi over 5. So what does the equation look like? Y equals, again, it's a sine wave. We're starting at 0. Amplitude of 1, and this is the sine of pi over 5x. There's the equation. You can write in a 1 in front there if you want to put that the amplitude is 1. Part B, it looks like the amplitude, let's change colors here. Looks like the amplitude goes up to 4. In fact, it starts at 4. So this is going to be a cosine curve, I can tell, because I'm not starting at 0. Amplitude is a +4 because I'm starting up. If I started down at -4, then it would be, amplitude would still be 4, but we would need to put the negative for the actual equation. Now the period, it looks like it cycles 1 full cycle. That's a distance of 6. So that would continue on to 6. So this means that the period is 6 is equal to 2 pi over b. Switching that around gives me that b is equal to 2 pi over 6, which is pi over 3. So what does our equation look like? Y equals 4 cosine pi over 3x. And that is how you find the equation.